talking about the changes in states of matter, and so the video is pretty self-explanatory. We'll just be going over the different changes in states of matter and should be relatively easy for you guys to follow along with. Just a quick little disclaimer, the video has a little bit of concepts that include moles, so it might be helpful for you guys to go check out the other video that we have up on our site about moles and come back to this video after that. It's gonna really help you understand the concepts and it's gonna make them seem much more easier. So without further ado, let's go to our first concept, which is melting. This is the first change in state of matter that we're gonna be talking about. So I'm just going to be going over the basic definition and then increasing in complexity and talking about the more complex concepts. So the basic definition is that it's transition from a solid to a liquid state of matter. And so we may or may not, you guys may or may not have heard of this, but it's just transition from solid to liquid, right? And then the melting point, ideally, if melting is the action of the transition, the melting point is the temperature at which the solid is becoming a liquid. So we have a new concept that I'm going to introduce that is associated with that, and that is the molar heat of fusion. The molar heat of fusion is the amount of energy that's needed to change 1 mole of a substance from solid to liquid or vice versa at the melting point. So let's break this down. First, it's the amount of energy, right? So we're talking about energy, and it's the amount of energy needed to change 1 mole. 1 mole, so the amount we're talking about is 1 mole of a substance. Remember, this refers to any substance, and it's going to be from solid to liquid or vice versa at the melting point. And yeah, so that's the concept of molar heat of fusion. It's going to pop up more in chemistry as you go into more complex concepts, but this is just going to help you understand those more complex concepts, so we'll build from there. And our next change in state that we're going to be talking about is freezing. Freezing is basically just the opposite of melting, so it's the transition from the liquid to solid state of matter. And as you can imagine, as we were talking before, the freezing point is the given temperature at which the liquid is transitioning into a solid. And just a concept I'm going to kind of introduce here. We were saying that the melting point is the point at which the solid is turning into liquid. Freezing is a point at which liquid is turning into solid. So if you think about it, these ideally are happening around the same place, right? Because it's just like this bar, and if you go from solid to liquid, then you're considering it the melting point. If you're going from liquid to solid, it's the freezing point. So ideally, these points are the same, just they have different names based on the context. So based on that, the molar heat of fusion is going to be the same for freezing, and it's going to be at the freezing point, which is basically the same as melting, except that it's going to have an opposite sign because we're doing an opposite action. So if you remember, I was saying that melting is the opposite of freezing because they're doing the opposite action, and so they also have an opposite of sign to represent this molar heat of fusion based on the action happening. So freezing will have the opposite sign as melting. So our next one is vaporization. And so this is the third state of matter, and it has a little bit more complex concept, but should be easier for you guys to understand after this. So its generic definition is that we're referring to transition from the liquid to a gaseous state of matter. So it kind of breaks down into 2 types. So there's 2 different types of vaporization. We have evaporation and boiling. So evaporation is only occurring on the surface of the liquid. So the liquid is becoming gas. And just to guys give you an instance of where this might be happening. If you think about it, we always talk about the water cycle and we say that the water on the Earth's surface is evaporating. That's really true. The water is evaporating on the Earth's surface, but it's not evaporating from within the Earth. So evaporation as this concept, if you connect it to real life, everyday things that we talk about, this is maybe going to help you understand it better. And so boiling is the exact opposite. It's occurring throughout the entire liquid, so not just at the surface. And a term that you're going to constantly hear when we're talking about boiling, and will become more important later, is vapor pressure. And that's the amount of force of the liquid trying to push itself up into the gas. And there are a little bit of kind of like qualification or requirements, whatever you want to call it, to boil. And so these requirements is that the vapor pressure has to be greater than the atmospheric pressure. So the atmospheric pressure is the pressure around us in the air surrounding us. So the vapor pressure has to be greater than that for the liquid to push itself up into a gas. And so the next concept or the next change in state of matter is condensation. Its basic definition is kind of just referring to a transition from a gas to a liquid. So a new concept that we're going to be introducing when it comes to condensation is the molar heat of vaporization. And so what this is the amount of energy needed to convert 1 mole of a liquid to a gas, or vice versa at its boiling point. So if you look at the vice versa part, what we're talking about is, remember, the boiling point and the point of condensation are, again, essentially the same if you were listening to the concept of melting and freezing earlier, just with opposite signs. So the molar heat of vaporization applies to both of these concepts, condensation and vaporization, and it's the amount of energy needed to convert 1 mole of liquid to a gas or gas to liquid at its boiling point, which is the same as point of condensation. And so remember the sign changes between condensation and vaporization because they're not exactly the same. It's based on the action that's happening. So you're going to either have a plus or minus based on the action. So the last two concepts we're going to be talking about are sublimation and deposition. So first, for sublimation. Sublimation is just the transition from a solid directly to a gas without actually entering the liquid phase. So this might be a new concept for some of you all, but you might have heard of dry ice. So dry ice is a great example of sublimation. So it's just a solid turning into carbon dioxide gas. And I encourage you guys to search up pictures of dry ice because that's definitely going to help when you're looking through and trying to understand more about sublimation. But then we have the exact opposite, which is deposition. And deposition is just a transition from the gaseous state of matter directly to solid without entering the liquid phase. So this is really, really simple concept, and it's going to help you more later when we're talking about more complex concepts. But this essentially brings me to the end of the video. We talked about the 6 changes in states of matter, and as always, if you have any questions or you really like this video, make sure to like the video and comment on it. If you do have any preferences for future videos or are looking for something different, feel free to reach out to us and ask us to upload different videos or come to our virtual classes, which we're opening soon with our talented instructors. But that brings it to an end. Thank you guys for watching, and I hope you have a great day.